Electrical installations in domestic and industrial settings, procedure from design to installation. Electrical installations, whether in domestic or industrial environments, involve careful planning, adherence to regulations, and precise execution. Here's a step-by-step guide covering the process from the design stage to the installation of electrical components. 1. Design Stage A. Assess requirements. Domestic installations. 1. Identify the number of rooms, outlets, and appliances. 2. Account for future expansion, e.g., additional appliances or charging points for electric vehicles. Industrial installations. 1. Understand the facility's layout and operational needs, including heavy machinery, lighting, HVAC, and automation systems. 2. Assess energy loads, backup power, generators, UPS, and special requirements like three-phase power. B. Load calculation and power distribution. 1. Calculate the total load, in kilowatts, to determine the power supply capacity required. 2. Design circuits and sub-circuits to balance loads effectively. 3. Consider peak demand, diversity factors, and safety margins. C. Select components. 1. Choose appropriate cables, circuit breakers, switches, and protective devices. 2. Specify the type of wiring, e.g., concealed wiring for homes, conduit systems for industries. 3. Identify lighting types, such as LED for energy efficiency. 4. For industrial setups, include control panels, transformers, and switchgear. D. Create electrical layout. 1. Prepare detailed schematics and layout drawings. Position sockets, switches, fixtures, and panels. Indicate wiring routes, conduits, and junctions. For industrial projects, integrate control systems and automation in the design. E. Compliance with standards and regulations. 1. Ensure the design adheres to local electrical codes, e.g., NEC, IEC, and safety regulations. 2. Consider earthing systems, protection against overcurrent, and fire safety. 2. Pre-installation preparation. A. Obtain approvals. 1. Submit plans to local authorities or an electrical inspector for approval. 2. Obtain permits for the installation. B. Procure materials. 1. Source cables, conduits, switches, distribution boards, and other components. 2. Ensure components are certified for safety and durability. C. Site preparation. 1. For new buildings, coordinate with civil and plumbing teams to embed conduits. 2. For existing structures, prepare walls, floors, or ceilings for retrofit wiring. 3. In industrial setups, ensure equipment and machinery are ready for electrical connections. 3. Installation of electrical components. A. Wiring installation. Domestic. 1. Lay concealed conduits, if applicable, or use surface-mounted channels. 2. Pull cables through conduits and connect them to distribution boards and sockets. Industrial. 1. Use conduits, cable trays, or ducts to route power and control cables. 2. Label cables for easy identification and maintenance. B. Install distribution boards. 1. Mount the main distribution board, MDB, or sub-distribution boards in accessible locations. 2. Connect incoming power supply and outgoing circuits. 3. Install residual current devices, RCDs, miniature circuit breakers, MCBs, and fuses for protection. C. Install components. 1. Fix switches, sockets, lighting fixtures, and appliances at designated points. 2. In industrial settings, install control panels, motor starters, and variable frequency drives, VFDs. Machinery connections, three-phase or single-phase. D. Earthing and bonding. 1. Establish an earthing system to protect against electric shocks. 2. Bond all metallic parts, such as enclosures, pipes, and machines, to the earth point. E. Connect to power supply. 1. Link the installation to the utility company's power supply or an on-site generator. 2. For renewable energy sources, solar panels, wind turbines, connect the inverter and battery storage system. 4. Testing and commissioning. A. Inspection. 1. Inspect all connections for proper tightness and insulation. 2. Verify that wiring follows the approved layout. B. Continuity and insulation testing. 1. Use a multimeter or insulation resistance tester to check circuit continuity and insulation integrity. C. Load testing. 1. Simulate real load conditions to confirm the system's ability to handle peak demand. 2. Test machinery and equipment functionality in industrial setups. D. Protective device testing. 1. Test RCDs, MCBs, and overcurrent devices for proper operation. 5. Handover and maintenance. A. Handover documentation. 1. Provide the client with a detailed electrical layout, component specifications, and compliance certificates. 2. Include instructions for safe operation and emergency procedures. B. Maintenance plan. 1. Recommend regular inspections to ensure safety and efficiency. 2. For industrial systems, suggest periodic testing of equipment and protective devices. By following these steps, electrical installations in both domestic and industrial environments can be safely and efficiently completed while ensuring long-term reliability. Thank you for watching Electrotech Academy. Share and subscribe for more informative, educative videos for both engineering and tech enthusiast professionals.